Just make that a little smaller. All right, I think that's all the technical issues. Anyone having any technical issues already? Okay, good. Okay, so hi everyone, I'm Jane, the postdoc here, a postdoc here. So today I'm going to talk about, the title of the talk is broad. It's Interactive Dynamic Visualization in R and JavaScript. Obviously, I can't cover everything. But it's going to be mostly R focused. So out of curiosity, who here uses R regularly? Okay, and who uses ggplot regularly or is somewhat familiar? Okay, great. And who here already does interactive plotting in R? Okay, so less people. Great, that's perfect. You're the perfect audience for this. Okay, because this is pretty, like I said, it's R heavy, it's ggplot heavy, and that's just because I looked around at different, so I started kind of from scratch actually with interactive visualization maybe a few months ago. I had done a little bit with networks specifically, but most of this stuff is pretty new to me and it's actually relatively new just as code. So I looked around and I'm going to talk a lot today about Plotly, which can build off ggplot, and I just, comparing the different packages, to me, this was the one that was easiest to integrate into my existing workflow. So if ggplot's already part of your workflow, then it will be relatively easy for you as well. We'll talk about a couple other packages sort of minimally, and I'll explain some differences, but like I said, we'll focus on Plotly through R and ggplot. Okay. So the goals of today, explain the logic and tools for interactively plotting what I'm referring to as static data. Like Pamela mentioned, in 2 weeks, I'll talk about Shiny, where I've referred to the data as dynamic. So what I mean here is, with the tools that we're using today, you create some data object, and that data is fixed. And then the plotting can do whatever it wants to on top of that data. It can use a subset of that data. It doesn't need to use all of it. But all the information that I'm giving it is basically fixed, which can be a limitation on what I'm able to do interactively, right? This one, maybe small, maybe large data set. Shiny actually allows you to interact with the data, build models dynamically on top of what's already there, subset the data in ways that you hadn't already thought of. So it's pretty much infinite possibilities as far as what you can do with the data. You still work off one existing data set, database, but you can create novel transformations on top of it. You're not wedded to this one data set. So we'll talk a little bit. So this is part of the DSI's visualization series, and it began with 2 weeks on really just best practices, what you want to think about when you're building plots. So I want to keep some of that in our discussion today. Talk about justification, best practices, how to use and not use interactivity, keeping in mind that I'm also somewhat new to this, so I'm sure I'll make mistakes too. And then we'll work through examples, go through some other packages, and then with whatever time is left, it depends kind of on how fast we go and what people want. Duncan will talk a little bit about how this is all happening when you write R code and then HTML comes out, what's actually happening in between. Okay, so why do we want to use interactive plotting? The first reason is that they look cool, which I crossed out. But actually, it's kind of valid. As scientists, which I'm guessing most of you are in some capacity, part of your job is to sell your research and get people interested, and interactive plots can help you do that. So you don't want to go overboard with it, and you don't want to add bells and whistles just for their own sake. But that said, interactive plotting can help people draw people into what you're talking about. So it's somewhat valid. But even stronger reasons to use it, number one is exploratory data analysis. So you can interact with your data dynamically in ways that help you see patterns that are difficult to see in a spreadsheet, in a data frame. And we'll sort of see a little bit of that actually. And the same for the user, right? You can present your data to a user in a way that it can help them do the same thing. Another big thing is, I should have asked before, so who's used Shiny before? Okay, so actually more of you have done that. So there's a good chance you've also come to kind of a limitation of Shiny, which is how do I deploy, or a challenge, which is how do I deploy it? And there are some issues there if you want, especially if you want to deploy it either for a large audience or you want to deploy it publicly, but also keep it behind a wall so not everyone can see it. If people don't know, if you can give someone your R code, sure, that's great, but if they don't know how to use R, then that's not really helpful for them. So an advantage of these things that I'm going to show you is that you basically end up sending someone an HTML file and maybe some auxiliary files, and they can just open it, right, in any web browser. Another big advantage, and we'll see this too, is you expose the data, right? So this kind of goes with exploratory data analysis, but when someone looks at a plot, if they see an outlier, for example, they can hover over that point and actually see what the data is underlying it, and that's very useful on both sides. Increase the amount of information you can share. So going with that is, right, with these interactive plots, there's almost no limit to the amount that you can expose about your data, but that is also very dangerous. And I've, in playing with these tools, come across this many times, is you're like, well, I can just basically include everything, so why don't I just do that? And the reason is that that just leads to confusion, and the message that you're trying to convey can get lost. So you still want to do a lot of decision making when you're building these plots and provide the minimal amount of information to convey your point, right? You still want to also start probably with static plots, build up to interactivity as needed, right? Again, you want to have an argument or have a point you're trying to make, and you want to convey it as cleanly as possible. And then the last thing we'll talk about, brushing and linking. So who here knows what those things are? Great, I didn't either like 3 months ago. And Duncan asked me, and I was like, I don't know what you're talking about. I actually did to some extent, I just didn't really know that's what they were called. But so we'll talk about what those are and why they're useful, and how you can incorporate them with interactive plots. And you'll see actually that in some cases, but not all, what you thought you might have needed a Shiny app for, you can actually do with these more simple to use tools. Okay, so I hope I've now justified why we want to use this stuff. Now I'll introduce to you my personally motivating example for this. So it's actually not entirely true because, like I said, I've done this with networks. And you can imagine actually with large networks, trying to show the whole network in one plot is basically impossible. Edges crisscross over everything else. So these kind of interactive tools are very useful in that context. But in a more a context you're more likely to see, this was the example that led me to start being really curious about interactive plotting. So what is this? So I have a friend he's done a lot of different political work, and it's kind of a side project. He started this nonprofit with a couple of his friends called Pizza to the Polls. Has anyone heard of it by any chance? Oh, that's great. Okay, so what they do is they find places where there are long lines to vote, and they send them free pizza. So you're waiting online. I don't think Davis has very long lines, right? I vote by mail, so I don't know. But you can, I'm sure you've seen, and you can imagine there are some places where you wait online for 2 hours. And all the people who started this nonprofit, they kind of have a background in this kind of civic engagement, and they're like, voting should be fun. So let's send people free pizza while they're waiting. So they gather, it's kind of snowballed. In the midterms, they sent over 10,000 pizzas to 41 states, which is bigger than any election they've done in the past, but they've gotten like some TV coverage and stuff, so it's kind of got picked up. And so they have all this data about where they sent pizzas, which also means that they have data about where there are long lines to vote, which there is actually, as I've now found out. There's some other research on that. There's some surveys. But this is an interesting another data set to balance that out. And so I was like, hey, send me your data. I kind of want to see what's there, see if I can learn anything from it. And then we can use it as kind of a publicity tool for you, whatever I make out of this. And we can also use it to kind of learn more about where there are long lines and try to, reduce them. And once show people where the lines are, then they have incentive to shorten them. So that's the main example that I'm going to use to kind of justify what I'm doing. For learning, teaching purposes, we'll use a different data set. So it's a built-in data set in Plotly. So that's what we'll use to test things out. But as a kind of proof of concept thing, I'll show you examples with this pizza data set. So to make sure that we're all going to be able to do this. Everyone, so I mentioned everyone should download what's here. So there's the link, and just click to download what's there. And then, so I'm working off the slides that are in the RMD file, the markdown file. But hopefully, you can follow along with everything I'm doing with this, just the intro to interactive R script. So you shouldn't have to deal with the markdown syntax. So once you've downloaded this repo, you should be able to open this .r file. So I'll give everyone a minute to do that. Is anyone, and please, if you have any difficulty with this, let me know. You should end up, oh, oops. You should end up with something like this. And then the first thing, once you get it open, everything, the first thing you'll want to do is set your working directory to wherever you've saved this intro to interactive folder. For me, it's just in documents, but none of this will work if you don't do that. Also, so I know Pamela sent this out yesterday, but there's a whole list of packages that you need. You don't need all of them for everything. If one thing fails to install, it might not be an issue. And I'm sorry, the list is kind of long. I wasn't really thinking about how long the list was going to get as I was writing this. But there it is. There you have it. So like, yeah, especially these last four, you really don't absolutely need. So yeah, are people on the same page? Does everyone have this? Who has this file open? Great. And who has the packages installed and loaded? You can just run this code. This code, all of it. Has anyone had any issues with those packages that I should know about? And, do we have a helper here or no? Which one is not? If that doesn't load right now, don't worry about it. That's like for one slide at the end. Yeah. Any other ones? Okay, great. So, okay. So I won't go through all the fields that are in that pizza data, but they're kind of what you might imagine: locations, times. I might have hid some of that from you. Okay. More about what that pizza data set looks like. Okay, so when I was working with that data set, the first thing I did was make a static plot of where all the pizzas were delivered. The character or the plotting size corresponds to the number of pizzas that were delivered there. But as you can see, it's not a great plot. So what is sort of lacking from this plot? I'm going to ask you guys. Why is this not a great? Yeah, that's a big thing. Yeah, right. I can give you a kind of, okay, I see that like the Northeast seems to have a lot there, I guess. And California, it seems like LA, San Francisco area, Bay Area. Yeah, I get like some major strokes. But exactly, yeah, precision. I can't really learn anything about which parts of cities from this plot. So what would I like to be able to do? Zoom in, exactly, right? And we're going to see that's just actually have the data set attached. And that means that we can both look at it. Right. It's not loud enough. Oh, I see. Thanks for coming to my TED Talk. Can you hear me? Is that only for the recording?
Sorry, guys.
Oh, probably. It's all good.
Okay.
Can you tell if that worked?
If I flag you, you can just turn that on.
Okay. Just press the bottom. Okay. Okay, so plots kind of come when you look at what you think of as the plot, it kind of has the data in there, and we'll see what that really means. I'll show you how to actually look at the structure of the output of your plot, which can be really useful, especially for customizing. And you'll actually see how these things get built. So one thing it helped me with, I couldn't figure out why a legend wasn't turning on, and I was able to use the structure to actually figure that out. So in terms of how we built, so I showed you that you can build something in ggplot and then translate it into Plotly. You can also start that process in ggplot, translate it to Plotly, and then add more things, or customize the interaction, or do whatever else you want to it. Or you can actually, there's a function plot_ly, where you can just start in Plotly to begin with. So this is a note from that thing I linked to earlier. It's like the guide to Plotly, but explaining that this Plotly function was created to support plot types that weren't supported or weren't available in ggplot2. So examples are like 3D surface and mesh plots, not things I use very much or ever, but some people do. That said, well, you won't necessarily be able to do everything from scratch in that plot.ly. And not every plot you can make in ggplot2 will have a natural transition into Plotly. So that's something to be aware of. But the standard types, any kind of scatter plot, you should be fine. Okay, so I mentioned 3 ways. There's 3 ways to build a plot. So open, if you downloaded that folder, open this options to build pizza Plotly. So this is just a demonstration of these 3 different ways to get to a Plotly object. I'll kind of walk through this, and then you guys will try out each of the 3 ways with that Texas housing data set. You already saw one of them, so you'll try out the other 2 ways, just because it's important to keep your hands moving and actually try this stuff so you remember it. Okay, so do people have this file open? I'll take that as yes. Great. So, so this is the first way I create the plot in ggplot. I added here, I want the state background in the plot. So if you ran the code earlier, I think it's in the bullet point 1, this code was there to actually get this us.state. If you didn't run that code or you didn't want to download that package, you could also just comment out that part and you'd be fine. But yeah, then so you go about building a plot. This is basically the plot, the static plot that I showed you to start with, but with a state background with it. And you can see what it would look like again. So again, pretty much what I showed you with state background. And then you can just throw it into ggplot. And this time I set the tooltip to just be the number of pizzas delivered. And I'm going to use, so you'll notice, right, these default tools that come up. By default, they all come up. You can control which ones come up. Generally, I don't mind having them there. But so this is actually one of the biggest annoyances I found, is that you have to keep changing which tool you want to use for interactivity. But so I want to probably zoom in on just the United States, the lower 48 part, and then pan, and then zoom again. Yeah, etc. Okay, so that was again the way of build the ggplot and then throw the output into ggplotly. Option 2 is, like I said, I start building the ggplot. So I'm going to throw this code in here, and you'll see what comes out. So now it's just the background, the state background. But then I'm going to say throw that stuff into plotly, ggplotly, and then I can add a layer, add a trace now that we're in the plotly universe. So I add this add markers. So markers are the equivalent of the point, g on point. I tell it which data set. So again, I mentioned instead of AES of like x equals y equals, now you'd have x squiggle longitude latitude for y. Okay, can you hear that? Okay. So yes, similar. I kind of think of it somewhat as like a theme, kind of an argument if you were in the ggplot world. But I can set like the axis limits, the title of the plot. Again, it seems like I'm setting things about legends quite a bit. And I can run that. Ooh, this should be 3.
you explain what SF stands for?
What is it? Simple feature. Yeah. So yeah, the underlying structure for work. So when I want to plot states, the data that I start with is like the points that make up the polygons of each state. And so this basically simplifies the process of going from those polygons as they exist and kind of lists within a data frame into things that appear in the plot. And so yeah, SF is going to be the thing, the kind of geometry or layer or trace that you want to deal with that kind of data. Yeah, give more to. Yeah. Yes. Yes. Yeah. Yeah. I guess I didn't make it to here, but I believe I had an example with that somewhere. I'll put it probably somewhere in the repo. But yeah, you could start something with ggmap and throw it into Poly. It's going to be hard to type with this microphone. So some things to point out about this approach, right? You have the similar layering, and we supply this text, again, the text and hover info. When I've been playing around with this stuff, I get a lot of this warning about no trace type specified. If my plot doesn't work like I wanted to, that probably means I tried to give it some parameter that particular kind of trace, like add markers or add SF, didn't understand. But I also got the warning a lot of times when things were working. So I would ignore it in most cases, just a heads up. Okay, and then I mentioned before that there's a way to look at the structure of the output here, and it's helpful. So let me show you what I mean. Just go with the last one. What? One second. Should all work. Oh. Okay, there we go. Okay, so when you do this plotly underscore JSON function with all the packages that you had to load already, this is what you get out. So you actually see as it's converting this structured list into something that you can interact with and see what actually happened here. So data 3 is because I have 3 traces of data that go into making this plot. So you can see this first one is going to be longitude and latitude, and I get to see that from looking at the X, Y's and knowing what my range is. Similarly, so I think one being for the points, one being for these polygons, and then finally, or no, let's see, so I think, and then this last one is the points. So yeah, so you can kind of figure out from looking at what these are, right? Let's see if, so like type here is scatter. These are all, so I guess all of them at a lower level are getting translated into scatter, like the polygons, the points. You can see, so another better one to show maybe is like, this is how the highlight interactivity is currently set. So for example, things highlight when I click on them, but I can change that as well. Yeah, so I would just say explore this, and you can see often, like, if I thought I had put the legend on, but I go in here and I find out show legend is false, then I know that I need to change to show legend equals true in that particular trace. Okay, so to make this make more sense, now I've kind of walked you through each of these and how to look at the output. I think it's time for you guys to just do it. So going back to the slides, right, we're at the point of this exercise. So using this Texas housing subset, which again is in that code, if you go to bullet point 2A here, you can create this Texas housing subset, and the first kind of ggplot But I'd like you guys to try out building the other two kinds. So starting it in ggplot and adding stuff in plotly, or building it directly using the plot_ly. You can find basically this example is mentioned in this online book. But yeah, so I'll just walk around and answer questions while you guys work on this and play around with it. If you get it to work really quickly, I would say just play with it and see if you can customize it in different ways. And if not, then what obstacles you're hitting. Yeah. They can't find that. Oh, it's a problem that our studio version is DSI now. They put that out. Yeah, I did that. Did you? I think it's just the first. No, it's not available. Yeah. That's what it said. I would say if the SS stuff's not working, just comment that part. Yeah, so just from source download that package. Okay, maybe I'll that'd be great. Okay. So it seems like some people are having issues with this USA boundaries. Let's see. So someone suggested if you're having an issue with the USA boundaries, like I said, you can just comment out anything SF. It just means your plots won't have a background, and that's totally fine. You can continue with the rest of the example, but if you'd like to try to get it to work, installing those USA boundaries package directly from source from this, if you just basically enter this code, let me make it bigger, into RStudio, that might work. You might have to restart your R session. Yeah. So you're trying so this is, just to clarify what you're doing now is, right, I've shown you the code again to create a plotly object by converting a ggplot object into plotly. Now I'd like you guys to try building basically that equivalent plot directly starting with plot_ly. So if you look, again, if you open the right, so instead of building it this way, to build it in the other two ways, and if you don't remember what I mean by the other two ways, open this options file, right, and see option 2 and option 3. So you're basically going to try to take this syntax structure for option 2 and option 3. But apply it to this Texas housing. You could use the Texas housing or the Texas housing subset data actually, and just try to build a similar plot in this way. So like starting with plotly adding layers would be one way, or starting with ggplot and then going into, so turning that into a plotly and then adding more stuff on the plotly side. So this is kind of open-ended. I just want you to build something with this data in these ways. What exactly you want to do with it, what you want the colors to be and stuff is up to you. But I just want to give you a chance to actually be typing and see what I'm talking about. If you have questions, just bring them in, and Arthur, Jane, or
Go back to that.
oh yeah, yeah. Yeah. It's okay to now. Right, so you can do it in the GD file. You're at you can set like your trees in yeah. So you can keep something more like data and then like text.
Yeah, it's.
You just bring the data and
Yes. If you go to the app.com,
So now that's done. It looks like it's slow check. Where was the data?
Right, so that's setting everything in here.
Okay.
Yeah.
Right next to you need to load and then
Okay, well, okay. Yeah, just play around with that. And the only thing I haven't actually tried to do multiple trains on all of the first time. I think you probably can. It's like the first trace might be like online, the second trace might be yeah.
really interactive. It's kind of just like, it's not.
Yes. Yeah, I realized I didn't explain that. I guess I just yeah, but so the pipe basically says, I'm going to start with this thing, and then you ever use the with? Okay, so normally, if I just said evaluate this again, right? If I just enter that on its own, it would say like pretty great behavior. I don't know what data you're like. It's like a vertical pipe in like on command line. Yeah. So it basically just says I'm gonna execute these commands. Yeah, I know this is basically my first. Yeah. You little yeah, there is a fire. Oh, okay, yeah. Thank you. No problem. Yes. Oh, right. So I created your so if you put down here. So US.state is my
Encountered. That's sort of going to happen with these packages, especially in these examples. I'm using a lot of different packages. Everyone has different versions than I did for some of them. And it's also this is kind of just kind of a general warning with this kind of stuff in general. But so just that it's all very new. It has unexpected limitations, conflicts. It's part of why I wanted you to see these 3 ways of building Plotly stuff. Can you hear me, Pamela? Is that work at all? Good. Yeah, okay. Because sometimes something just won't work in one of these ways. You can try it in the other way and maybe it will work. One thing that I actually have encountered, and I think maybe he's encountering too, is sometimes you build a plot in ggplot, everything's fine. You say ggplotly of that thing, and it doesn't work. And it's because you put something into the plot that it just didn't know how to convert. And what exactly it was can be difficult to find, and it won't exactly tell you. So generally, the solution is just to make a simpler plot, see if it works, and keep going that way. It's not ideal. But that's just kind of how this is as they're still building out all of the code base to actually translate all the things that you can do in ggplot then into Plotly. Okay, so let's move on to some other things. Back to slides. Okay, so you've all built multiple plots now in Plotly. Let's see. So I won't talk too much about this because what you actually want to do and how you want to use this stuff is going to be very independent and personal. But just a little bit, right? You've seen some of this, but if you're building things directly in Plotly, the general idea for customizing, say like, a scatter plot is you have a color and colors argument, a symbol and symbols argument, etc. And so color will be something like, telling it either one constant color or the variable that you want to use for the color. And then colors would be something similar to like the scale arguments in ggplot, where you tell it like the range of colors, the list of colors, or like, the possible values of the symbols. So that's the general idea for Plotly on the Plotly side. Style is the general argument for editing a trace after you've converted. So I built something up in ggplot, and now I've decided I want to like change the line widths, for example. But maybe I only want to do it for like some of the traces. I can do that in the style function where I set the traces that I want the thing to apply to, and I can have multiple calls to style. By the way, so some people asked about this pipe operator. I kind of forgot to mention anything specific about that, but for people who've never seen it, you can basically think of it as sending the output of here to be like the first argument in the next thing. Long story short, if Duncan were here, he'd probably pull his hair out at me saying that. But yeah, that's how you can think of it. If you actually look at, say, the help for like style, right? For Plotly, you'll notice the first argument here is actually P, but we haven't actually been setting P. So what it's doing is it's saying the plot that you've already been working on, that's your P, that's like the first argument if you're using the pipes, and then everything else is set the way that we've been setting it. Okay. So right, style would modify individual traces, how they appear. Layout, again, it's going to be more of the global theme type arguments, whether you want to show legend, x-axis limits, titles, drag mode. So I'll show you what that would do. Let me go. So we are here. So this is the code I was just pointing to. So you can see the modifications, right? The width of the second and third lines is now bigger. I set that with the style. And then the drag mode, right? If I drag around here, the drag mode equals lasso, made it so that when I drag, I can do it in this kind of sketch mode. And similarly, like to what I mentioned before, right? I can customize another plot. I can set the range of possible symbols using the symbols argument. Let's see what that looks like. Somehow that did not work. Why? There we go, sort of, should work. Okay, so just to get what we're trying to get at, right? Take the plot, add markers, and then I can set the symbols to be cross, square, triangle, and I can actually see that over there. Okay. So I put in an exercise here, but since we just took about 10 or 15 minutes kind of on our own, I think we'll just skip that and you can try it on your own later. And let's move on to the next kind of idea, which is I mentioned before, when you have this Plotly object, there's data inside of it, right? So if I do Plotly underscore data of that last thing, say, and actually, I'll show you two things. So that will actually show me what the data was the main data set that went into this plot. And it's this Texas housing subset with 72 rows. I can also, even though this Texas housing one modified is a plot, it has an element called X, and that element X has an element called data. So that's another way that I can look at the data that's in there. And this time, actually, let me look at the first thing that's in there. This will actually, so the plotly underscore data told me the main data set. This is actually giving me some structure too when I did this X $sign data. The first thing, so again, this I did that, and then I called the first element in that list. What came out was this stuff. So it's telling me what the X is in that first element, what the Y is, all the text that it's going to show. And then some other, like the type of trace that it is, it's a scatter, line width if I had lines and stuff like that. And I believe you can just modify all this stuff directly if you want to. If you can't figure out any other way to do it. And then when you plot it, you'll see those changes. Similarly, like the second would give me the second trace, whatever that is, if it's there. All right. So because there's this data object that if I call plotly data, it will tell me what the data object is that's directly associated with this plot. I can actually work with plots in a way that's similar to how I'm used to working with data. So who here uses like dplyr and pipes? Some people, but not as many as use ggplot. Okay, so if you use dplyr, you're used to this kind of syntax of I have an object. So normally this would be like a data object. And then I'm going to do operations on it kind of sequentially. So I might group my data. So this would normally be data, but I would group it by, individual combinations of month and year, for example. And then I can summarize. So in this case, I'm going to summarize by taking the overall median at each time point. And then I can add lines on top of that. So I'm kind of free-flowing, working back and forth with modifying my data and then modifying the plot on top of it. Just kind of weird and different, but it can be really useful. So as an example, this would give me this is going to give me this, okay? So the big difference between what I showed you before and now is that I have this thick black line that shows the median over time. And actually, if I scroll down over here, that's going to be the last trace listed. And I could click it, double click it, sorry. And it's weird. Okay, so it's grouped differently. This last one is grouped differently than the other ones. So if I want to turn off all but one of the other ones, I have to double click on one of those. They all turn off. And then this one kind of turns on and off on its own when I click on it. But that can be useful, right? To see this overall trend plotted on top of the individual cities over time. And again, it was this weird thing where I started with a ggplot, turned it into a plotly thing. Then I took the plotly and I, again, treat it, even though it is, I think of it as a plot object, it has a data object. So I can do these data operations to it, and they actually operate directly on the data. And then I can go back to operating on the plot thing and add this line, which changes how I see the plot that comes out. Yeah?
You did that in ggplot as well.
I haven't done it, but probably, maybe. A ggplot object would also have data associated with it. Has anyone tried that? To do the same kind of workflow of modifying the plot, modifying the data in the plot by modifying the plot object? Yeah, I'd never really thought of it as something to do until I was playing with this interactive stuff. So Not sure. But the one drawback, so I'm not going to show it now, but you can look at the structure of this object as it comes out, and you could look at specifically, actually, I will look at this part. So I mentioned a couple times, but I didn't necessarily write it out, right? There's this plotly underscore data function, and I can apply it to the plot object and see the data. If I say ID equals 3, that means I want to see the data associated with the third trace. So let's just actually enter both of them so I can show you what I mean. So if I do plotly data here, so and then plotly data. ID is 3. Either one really will give me the same thing, but they're going to give me versus. So remember, I started this plot with this thing, this tx.ggplotly. If I call the data of that, the original thing, you'll see that it's fairly large. It's over 8,000 rows. But when I did this sequence of commands where I summarized the data into this median row, what I ended up with was, to show you again, was actually only 187 rows. So I've managed to keep the full aesthetics of the plot with all the different cities, but the data has been summarized and subset in this way, where now it's only 187 rows. So that can be an issue if I then want to change something or add something in the plot where I need that original data, right? So the shrinking thing can be good, but it limits what I can do in the next step. So for that, there's this feature add_fun function. And what that allows me to do is I'm going to add things in a very similar way to how I added them before, where inside here, make this even bigger. I'm taking a plot. So this function says, give me a plot, and I want you to, in this case, I had to ungroup the data. So be familiar if you're used to dplyr. It's going to be a little weird if you're not, sorry. But I can filter it so that I only look at the city called Houston, and then I can add lines that correspond to Houston, right? So that's what this function will do. And similar, I can do the same thing for San Antonio. The major difference if I do it this way with add fun instead of just directly with like a group by or summarize is that I don't modify my original data. So it kind of, if you think of this data plot pipeline, that's not my term, that comes from Plotly and the author of that online book I mentioned. If you think of it as like when I summarize, I operate on this one pipeline and I'm narrowing the data as I summarize. If I use add fun, I kind of branch off and add things, but the original data pipeline is unaffected. So if I do this, let's go back here. Just enter that code I just showed you, right? And I do Plotly. So I still added, let me show you, I still added a couple individual lines, not summaries, but individual like Houston or San Antonio. If I get the data of that last thing, you still it still has basically the full set of rows. I didn't just knock it down to having 2 rows for the 2 cities that I looked at, or 1 row. Okay, so that's a nice feature, this pipeline, and the fact that you can kind of branch off of it.
Is that function Plotly?
That's a Plotly, yeah. A Plotly thing to add fun, yeah. And I can define a function externally that maybe takes the city name as an argument, so I don't have to keep doing that add fun for every city. If I want to do it for 10 cities, I can just call that external function, takes a Plotly thing as its argument, and returns maybe a line for just 1 city. And that's in, again, that online book. You can see that specific example. Okay, so something that's simpler to learn and can also give you kind of a lot of bang for your buck is a range slider feature. So I would like everyone to enter this code. So it's bullet point 5 in the intro to interactive and see what happens. Now we'll press C. Okay, so all I had to do, if I look over here, all I had to do was take a Plotly thing and add an argument called range slider. I gave it a start and an end, but I don't even really have to do that. It'll have default values anyway. And I used here the fact that I could call the data directly. So again, using like from the Plotly $x $data, the first thing, so you'd have to play around to see that this is there, but the first thing is going to be a data frame or a list, sorry, and if I look at it, I get the length. So like, let me just show you what I mean. Right, I can use this data to my advantage and see that the X object is this long, and that will set my range slider. But the important thing is that even if I just did this, right, even if I just add range slider to my Plotly thing, I get basically the same thing out. It just doesn't look quite as nice. But what it gives me is a lot of functionality, so I'll enter the nicer looking one. So yeah, it gives me a lot of functionality for me having done very little work. So this is all the data. It's kind of hard to see what these are, but if I use this range slider to set the range of time that I want to look at, I can get as much or as little detail as I want. Now I can actually read these to some extent. So an interesting time in here is, I can set the end back too. Let's look at like 2007 to 2008. You can kind of see, unlike the overall trend in this period, recession era, it's pretty flat, right? This climb that I was seeing before starts to flatten out, for example, right? So it's just another way to zoom based on time that, again, one line of code and you've added this to your plot and you can explore this time element, which you weren't able to do before. Okay, so now I think we should probably take a little break. So what I'm going to do is go back to the slide. And show you, just so you can see, so this was like kind of stage 2 of me building these interactive plots for the Pizza to the Polls people. So when I added it in Plotly, and the code is in here in the intro to interactive, under interactive pizza plots, you can see all the code I used to make this. But so I've added a couple of the features that were lacking before, right? So I can zoom is a big thing. So question marks are people reported a long line, but they didn't actually deliver anything there. Pizza is where there are things actually delivered. And an interesting area, but we can't quite see it fully here, is this is near Atlanta. So you can see so this might be hard to identify, right? Especially for me, I don't really know what all the suburbs of Atlanta are. If I put my data in a table and then I organize, say, like by city, I would see some things that were labeled Atlanta, but I'd also see a lot of these suburbs like Marietta and Lawrenceville, which I wouldn't know meant Atlanta. I mean, if I saw the state was Georgia, I might figure it out. But it's pretty nice to actually see them on this map and be able to see, okay, all of these suburbs are basically Atlanta, and I know there was like a close election in Atlanta in the midterms, and that's probably has something to do with this. Okay, so let's take a little break, but you can, if you're really excited, play around with the code used to build that plot I just showed you. And then after the break, we'll talk about linking plots and that brushing stuff that I mentioned. All right, so I hope you guys have had a little chance to play around with this. Oh, this was an interactive plot that I can close now. And where are my slides? They were right here the whole time. Okay, just go to the next one. Okay, so now we're going to talk about the other main thing I wanted to introduce, which is linked plotting. Okay, so we talked about Plotly and the Plotly package. You also, at the beginning of this, installed a package called Crosstalk, which is going to be the main way that we are going to link plots, that interactive plots on the page. And it's a pretty simple main idea, which is that I take a data set, like the Texas housing data, and I create a new object, which is a shared data object with this syntax here. I could just give it this. So let me make this bigger again. Up to here would basically just say take the Texas housing data and make a shared data object. This additional argument says I want to use city. Let's actually see the arguments. So shared data. So I showed you city was going to be my key. So when I'm trying to link different plots, the key argument or the key variable of the shared data object is how it's going to link them. So what's going to happen is I can select object or objects within a plot in one panel, and anything with the same ID or key will be highlighted, or something will happen in an adjacent plot. But it's the key that tells it how I want to link these two or multiple plots. The group, so we'll come back to that, but this is the group. Sorry, I should have just left this out of here, but focus for now on, I'm taking Texas housing, I'm creating a shared data object called, in this case, SD, where the key or ID is the city. So now just as an example, let me just enter this code. It's in your intro to interactive thing. So you can actually see what I'm talking about and why you'd want to use this. Just enter all this code. Boom. Okay. So what this is showing, I can get, is a relationship or if there's any structure in data that's missing in this data set. So when I click or hover on a city, this case, Collin County on the right, I would see how much missing data it has. Unless, in this case, actually, this one doesn't have any. So let me work from the left here. So when I clicked on Odessa, I can see it's missing all of this beginning data. And so accordingly, it's one of the highest, in terms of the amount of number of months missing, it's one of the highest, right? And I see that visually on the right. So this would be a good, I mean, probably in something like missing data, you can summarize quantitatively. You can just go through the cities and see which ones have a lot of missing data. But you could also at times want to know if there are specific ranges or if multiple cities have the same range of missing data. You can imagine a case, maybe something slightly more complex, when this would be very valuable. And similarly, I can select, oops, box, select. Oh. There we go. Okay, so whether or not I can actually select multiple things at a time is a setting that I can set. So I guess it's set to not allow that. There, it can also set how I reset everything. I'm not sure what this is set to, but you can set it so that like a double click or something else makes it makes this all reset. I'm not sure what this one is. Anyway, so you can play with that. But this gets to the basic idea of why you might want to do something like this and shows you what I'm actually talking about. And again, it's this shared data object. This makes the whole thing possible. Once you've created this shared data object, just to go through, you build your plots in really the same way that you did before. So P1 is one plot that went into what you just saw. It took a base Plotly thing, added some more summary and other aesthetics on top of it. Similar with P2. But it's all working, it's just working off this SD data set. So the shared data thing functions just like any normal data frame you'd be working with. But then how did I make those plots show up in the way that I did? That was the subplot command. So subplot, there's some description. You can just look at it here, right? I'm taking the first plot, the second plot, and then giving it stuff like a title. So I was mentioning, as I was playing with it, I was like, oh, well, I actually don't know how to set the highlighting. So one thing it did was it selectize equals true actually did this thing. I can actually select a city. But this dropdown came out of setting selectize equal to true. And then there are definitely more highlighting. So let me just, right. So that would give me Brazoria County. Who knows where that is, right? So when you have a lot of cities, like something like this can be really useful. Yeah.
So if we can still making this into a decision-making process, because usually when you're building blocks with time things, you have to look. This seems to require some forethought into like what elements you want to link and what variables are actually going to isolate.
Yes.
So how would you do that?
That's a great point. So I think, and that's why I wanted to include that pizza example too, because I have a lot more logic in how I do things for that case. This, I just want to show features and how they work in the code. But in the pizza plot example, why don't I just show you right now? So this isn't a linked plot, but I'm specifically interested in variables that I listed before, like the closeness of the election, here I'm showing the percentage non-white in a specific county. What were my other things? The like other voter variables, like is there vote by mail? Are there voter ID laws, right? So I know those are the variables that I want to show. So I don't have it here, but another version of this would have a dot plot of isolating this counties and this specific variable, like percentage non-white, so you can actually see the distribution. And then you can select specific ranges in that plot and have them show up on the map.
Okay.
So when I know I want to link those two variables, then that kind of dictates.
You're talking about like the variables that you might want to show, what kind of data those variables represent, and then what kind of plot would best represent those data simultaneous with a whole. And then
Totally. Yeah. Yes. And again, I would definitely still create static plots first. It's so much easier, right? So I can make a histogram of the distribution of this like percent non-white variable, for example. I want to see what that looks like first, right? I can create like a simple linear model of like pizzas to that variable, see what that relationship is. Build those things that I'm thinking I might want to put as panels. And then if it seems like there's a relationship here I really want to explore, and I think maybe it's like a nonlinear, multivariate type of relationship, that's the kind of thing I'd want to put in my interactive plot. And we'll get to another example. I showed this one because I built this with an external data set that I didn't want to foist another data set on you guys. So you can't actually build this plot, but we'll see an example with the data that you have. Okay, so I was talking about subplot. So subplot, I can take two plotly things or multiple, throw them into subplot, and the output is also a plotly object. So I can actually even put ggplot objects in there, and it will return, it would be similar to just saying ggplotly of that thing first. It will actually automatically convert them to plotly objects. It also means that you can put like a plotly object that contains like a subplot output, so like P1 and P2, you can throw that into a larger plotly or subplot, sorry. And so it's like recursive, like you can have a subplot within a subplot, but I don't have an example of that. So someone was asking before about facet wrap, and this is something I played around a lot with too because I use it a lot when I'm using ggplot. So I can create, so for those of you who aren't familiar, if I want to create, say, a bunch of different plots for each city, if we're using the Texas housing example, in ggplot, I use a facet wrap argument that automatically breaks out a plot for each city. I can convert that to a plotly object with this ggplotly argument or function. And it will, so it implements that like you're calling a subplot, where the default is that each column is like its own plotly thing, and they all share some kind of an x-axis. But you can, without getting details, you can imagine it as another instance of subplot where all of these individual plots are plotly things. It also means the behavior can be a little weird, but okay. And so we've only talked about plotly objects, but the class of a plotly object, oops. No, that's not right. What'd you do? What? Oh, no. Hold on a second. All right, sorry, talk amongst yourselves. My thing just quit. That's annoying. It's just the project I was working on it with. What? Okay, should take us back. No. Why? Sorry. What? Okay. Okay, I'll just load things as I need them. Okay, so we're here, and okay, so going back. So P1, this thing that you were looking at before, was a plotly object. If I look at the class of P1, it's plotly, but it's also this thing called an HTML widget. So plotly objects, and then these things that I'm about to show you, will all have this class HTML widget, and that's basically the class of things that I can work with crosstalk. So anything that's an HTML widget, I can basically turn into a panel of a linked plot. So an example, so that this makes some sense. Come back to this, but there's a widget called data table. So simple code here, I can enter this. So this part of the code is just so that you can actually see it in the markdown slide, but that interior, if you guys enter that, and let me increase the number of entries. So it's, the package is called, is DT capital, and then the main function of that package is data table. I'm going to give it my data, Texas housing, and then this options will tell it how many, by default, how many things to list in this table. So let me make that 10. So this is the output. What? Why? Okay, there we go. this is the output of that. So, okay. This is the output of that. It's similar to like what you see with Vue in RStudio, but it's just a chart of your data that you can sort. So I could look at sales, for example, sort so that Houston is going to have the most sales at any given time, and do that these kind of different sorting or search, for whatever city I want to see. So you can see it's a useful way to have one of your data views, and like I showed, it's pretty simple. You just call the data table function on your data. So that's an example of another HTML widget that you might want to link. Other examples, I'm not going to go through all of them, but D3 scatter for scatter plots if you want something else, leaflet for maps, a summary widget thing, a 3D widget. There's, I don't know, about a dozen of them that currently exist, and you can also write custom ones if that's what you're into. So let's go back. So I mentioned in the earlier slide, anything that's an HTML widget, I can throw in an arrangement. I can use this BS calls function from crosstalk to arrange different plots that I want. So an example is here. Actually, so sorry, this is a little weird. Let me just show you the example first, actually. So, okay, so sort of an answer to an earlier question. It's hard, even though I don't remember this version, even though I can like scale plotting symbols to the number of pieces that were delivered in a location, it's hard to look at the map overall and see like, okay, what were the places with the largest, the most deliveries, right? So that's where something like this can be useful. This is a dot plot of the x-axis is number of deliveries, and y is the number of places that number of deliveries were made to. So this is telling me that of the places where anything was delivered, usually it was like in the 0 to 20 range, but there were some places where there were a lot delivered, right? So I can highlight those and actually see where they were. So now you can see why this would be useful for exploratory purposes, right? So I can see, somewhat surprisingly to me actually, like near LA had, let's see this, Palmdale had a lot delivered. I don't know why. One theory I have is that the LA ballot is so long that it makes lines longer. And similar, and then I think this is near like Chicago, and then going back to Atlanta, we saw earlier. Not sure what happened there. Also, a warning is that in this data set, which was given to me, some of the cities are listed incorrectly. I didn't do that, but every now and then I just noticed that. So if you see something like that, that's why. It could be easily cleaned using the addresses. I just hadn't done it. So yeah, that's how this dot plot thing, which actually is implemented as a scatter plot, links to this map plot. Similarly, I can look at those LA-ish looking places you saw before when I highlighted come up easily in this table, which actually continues over here. So you can use the table. I only put a couple variables in this table for just to keep it small, but you could put a bunch of variables in a table like that, sort by different ones, and then.
When you zoom in to the map, the plot is changed as well, the distribution plot.
No, for zooming as it's currently set, I'm not sure if you can set it to. I think you still have to highlight what you want. Zooming will not on its own. But you would basically do a combination of like zooming and box selecting. Yeah. So currently what's happening is I highlighted this top row of the table, and I can see which city that corresponds to. And I believe the default here is I can highlight multiple rows, and now I see multiple things over here. Okay, but so this kind of arrangement is going to be implemented with, in general, when you're using this crosstalk package and shared data, this BS calls function. And the help page is not particularly helpful because basically it tells you you can put in a width argument, which will set how much of the page width-wise these different columns are taking up. And then you basically can put in your plots. So normally you just put in like P1 and P2. But what I'm showing here actually is that the output of this is just basically HTML that renders your page. So you can actually add HTML yourself. So if you don't even want to mess with this, you can ignore this part. But it can actually be very useful because this is basically the only way to customize this. So what I'm doing here is I'm creating a list, and then I'm using functions from this HTML tools package. Sorry, I know I'm layering a lot on you right now, but basically built-in function and packages in R, or not built-in, packages and functions in R to work with HTML. I'm leveraging those to put in custom HTML that will influence how these plots render. So if you saw, so I put in like this text, these are, which was right aligned, and then linked plots, which was left aligned. If I go back, and you actually see that. You can see how that rendered. If I hadn't done that, I would just get these two side-by-side plots, but this was how I added this text up here. And someone asked me actually about using these kind of plotly objects or other HTML widgets with Shiny. So I can actually, I think it's in the code. So similar to how I just told you that basically I can embed these things in other HTML arguments or combine them with other HTML. I'll give you an example. Where's that? So it's sort of written down here. I didn't expose it to you, but let's just do it. Yes. So now I'm taking that P1 and P2 plotly objects. I can throw them into Fluid Page. Like if you're familiar with Shiny, you can do any of the Shiny layout stuff you want to in Fluid Page or Fluid Rows or any other kind of page layout. And then I can throw that into the BS calls. But I need the Shiny package. And I get the same thing out, right? But it's just another way to customize this. Okay. So I kind of showed you what this does and hopefully justified the logic of why you'd want to do this or something like it. I didn't walk through the individual bits of code to create this, but they're in this file. And I think it's probably too much to try to go through it all. But if you go to this linked interactive, so you can want to focus on this one part. Okay, so this linked interactive pizza plot thing, that's all the code that went into making that panel plot. You can see like how I created a dot plot. Unfortunately, the ggplot dot plot doesn't really translate well. It has actually kind of weird defaults to begin with, and I found that it didn't translate well, so I just made a scatter plot that did the same thing. But you can see I created each part of the panel and then created the overall plot. But like I said, I don't want to go into it. I think it's probably too much, and we have other last things to talk about. So I've spent a long time now talking about Plotly. And a little bit less time talking about how you use crosstalk to link Plotly objects or other HTML widget interactive plots like data table. So I just want to mention, and here actually is another way to see more demos and examples than what I've given you, which is also built into Plotly. As you guys have seen, working with this requires a few different packages. You want to bring in other data, like, you know, geographic data to make some of these plots. It ends up being a lot of dependencies, and you can hit, and like I said, this is all relatively new code. You can hit a lot of unexpected bugs and limitations. So just something to be aware of and not get too frustrated by. So the last thing I want to mention in my part is other packages that do similar things. I said before, the reason I chose to focus on this one is because of the transition from ggplot into Plotly was really easy, and it's very well documented. But there are other packages in R or in other places to do these kind of interactive plots. And two that I'm just going to mention quickly is Bokeh or Bokeh and HighCharter. I actually really like the general flow of Bokeh, and I actually like the defaults better. But it's not as easy to convert from ggplot. So it has a similar structure where you kind of have data, a main argument, in this case it's figure, and then you layer on things. So instead of like add lines, it would be ly, or add markers, it would be ly_points. But it's a similar idea of like layering on different geometries and aesthetics. I actually also think it's a little bit easier to control the different interactivity with Bokeh. I'll just show you a quick example of what a Bokeh output would look like. Hold on, just to create this again. Okay. So you can see, it's just default aesthetics are different. I'd probably want to move this legend over, but I still get the same kind of default hovering. It shows me the underlying data. And then last thing I'll mention on this is the HighCharter package is another one. I haven't found a reason personally to use this. I like the defaults in Bokeh better than it, and I found that it was easier and a more familiar syntax to work with. But there might be certain plotting templates. There's like so many different like plot types that you see now all over the place. There might be one that's implemented in Bokeh or HighCharter that you can't really access or isn't coded up yet in other packages, so that might be a reason to use it. And again, the syntax would be something similar to what we're seeing. The main function, in this case, is HighChart, and then you add layers of data and aesthetics, so something like this. Sort of up to you what you like, but again, these are all customizable, so don't judge too much just by the defaults. And then you can compare this last bit of code compares. So I'll just run this for you so you can see what the same data would look like in the default settings in each of these packages. So I created a heat map of the Texas housing data, where the entries that you'll see in a second have to do with correlations between prices of different cities. And if I just throw that into base plot, it looks something like this, and it's hard to read. But this is somehow visualizing the correlation between housing prices in different cities in this time range. If I throw it into ggplot, it looks like this, which is much more useful, and the default has actually the names listed. And I can turn this text too, so they're actually somewhat readable. But what I really don't like about this is that I have a scale. And so I'm using color, and you can see it even worse here than I can actually see it. I'm using color to convey the strength of these correlations. And there's like, you know, a guide on the side to tell you which color corresponds to which number. But it's your mind cannot possibly know what this shade of blue is supposed to correspond to. It's just, you just can't perceive. What's that? Exactly, they're not, and I can't. There's no obvious way to make them distinct enough without adding some other like level of complexity. I guess I could discretize the shades, and then it would be a little easier. But that's more work. What I'd much rather do, it's a lot faster, and especially if I'm just doing exploratory analysis at this point, It's just no. So I wanted to do an experiment. It's going to be a little hard. We'll see if it works. So even though I know this is kind of hard to see, can you guess what value like this is? The second, what would you guess? So it's somewhere between 0 to 1. It's kind of dark. So maybe it's closer. Well, it's kind of dark. Again, you can't really, maybe it's closer to like 0.5, 0.4. Okay. 0.4 maybe. Sure, let's go with 0.4. Let's see what it actually is. So this plot has the same exact appearance as what I showed you before, but I can actually see what the data is. So we weren't too far off. It was 0.56, and I could round that and it would look nicer, right? But this is such an easier way to navigate something like this. And this is actually like a realistic use case. I can actually see what these correlations are. You know, I might, the coloring helps me know which areas I want to focus on, but I actually want to see what the values are. And I certainly don't want to navigate this in the form of just a 100 by 100 matrix. That's going to be more painful. Okay, so then last, just to show the same plot default in bokeh looks like this. They seem to prefer a default of green. It's decent. I would want to move the legend out. Actually, one thing is I like the zooming better in bokeh. There were actually, where do I read? Actually, and also another thing is I think they have a wheel zoom that Plotly doesn't have, but whatever you like. I think there are tooltips. There should be. Oh, weird. I guess not. I thought there were. Oh well. So default is none, but you could make those appear. And then last, the high charter version, and the default there cuts off some of the names, which isn't nice. Right. I don't want to know every other city.
So the high chart one was kind of cool. It looks like brushing.
Yeah. So that would be maybe a reason to use it. I think, I haven't tried, but I think that's probably something you could add to a Plotly or a bokeh thing. But yeah, it's not the default, right? So if you just want to do quick things and explore, then it's nice if the defaults do what you want, and that might be a default that you want. So, but that's just a heat map too. Scatter plots are going to have their own intricacies and peculiarities. Okay, so that is pretty much a subset of what I wanted to talk about. I'm sure I left out a lot of things. With this, I will hand it over to Duncan to just give a little idea. So I hope that, that you found that in the last couple hours, you feel like I can make an interactive plot. It'll be a useful tool for exploratory data analysis or sharing my data with other people. And I only had, like I said, only had to invest a couple hours to have like basic functionality. Customizing the stuff will take longer, but is a couple hours. However, I basically gave you no idea of what's actually happening. I told you can write R code and somehow HTML will come out. And I give you a couple ways to look at what you're creating, like the plotly_JSON function shows you the output in this organized list form, so you can kind of navigate what you've actually done. You can look at the underlying data, right? But in terms of how this turns into an interactive rendering thing, I didn't tell you, and I think some people would say that's kind of a dangerous thing to give you these tools without telling you really how they work. So to give you a little bit of an idea, Duncan will talk for some time about how this magic happens. Okay, so do you want to plug in or? Yeah.
So some of this, so what I'm just about to tell you about,
Let me give you this. Yeah.
90% of you have no interest in what I'm about to say, but I'm used to that, so that's okay. Yeah, thanks. So it's, but it's, I don't know, it's Jane and I were talking about this. It's useful to know what's going on underneath, for two reasons. One is something possible? Can you actually do something? If you know what's going on, you can figure out is something possible. And also, there's an element where this has grown a lot over the last years. There's R packages for making these plots, and you should really use them because nobody wants to program at the lower level that I'm going to show you now. Okay, so reuse this stuff. But a lot of the fun who's just asking, how do you compose a plot? I'm sort of, I mentioned that we did a principles of visualization workshop a couple of weeks ago, and I said it's really hard to actually compose good static plots. It gets significantly worse when you go into the interactive realm because now you've got to think about a whole of the different purposes and a lot of different ideas, and so it's much more complicated. The plots that Jane was showing you are nice. They're cool. I remember I had a boss, and when I worked in Bell Labs, a boss said, "Oh, that's really cool. What is it?" It spins, it runs around, but it doesn't necessarily make things clearer, but it's cool. A lot of the defaults in some of these packages are just merely ways of looking up the individual data values, which is we often use a table for. It's not clear that they're actually making a phenomenal difference, but yet building good dashboards, which Jane will talk about in 2 weeks with Shiny, can go a lot further when you actually get beyond these canned plots. Okay, and there's really no magic to how this works. Okay, well, the magic is that some people invested serious amounts of money in building the web browser. Okay, and making JavaScript very fast. Okay, so everything sits on top of HTML and JavaScript and SVG. So I'm not sure what's happening here. So what are we going to show? Okay, basically, I just want to show you what the anatomy of these plots are. Okay, just so that you know. If something doesn't go right, you can actually low level. It's not pretty. Okay, and it's a lot to learn, and it can be very off-putting. But it's actually not very hard to learn. And how do you fix things? How do you debug things? You're going from. I mean, one of the real problems that you actually have is that you are going from an R data frame and some functions here, some R functions, and you're going off into the web browser, and we'll see in a second. You really can't look at the web browser. You can't look at what the HTML is being generated and understand what it's doing because it hasn't made a plot yet. Okay, so when something doesn't work out right, you're just going to be hit and miss. You're reading the documentation, that's great, but if something just is very, very close, but not quite right, you may need to dig into what's going on here because you have no control because there's so many layers in between you and the actual plot. And then you can think about, Jane was just alluding to how you actually use subplot and BS calls and stuff to actually construct a different HTML document where you can put in titles and text and images and other stuff. Make a very nice plot. You can do that from within R. You can do it outside of R, but so you can customize how the page is assembled, but then you can also actually go in and change what these things do. So the actual linking, what happens when you click on a point, or what happens when you mouse over a bar. It's not particularly hard. And again, this is super, I mean, I'm hesitant to even tell you about this stuff because it can be off-putting. Here's a quick example. A woman down the back of the room. She was so we're building a user interface. This is all sitting on top of HTML and JavaScript. I wrote this code because it's the simplest way to deliver a user interface for them to enter data. Okay, so I fixed it up. We did this a couple of months ago, and then we added some new features just this week. I did it late last night. I sent it. It's ready to go. Apparently there's a bug in the code, okay, because we didn't fully check it at the last minute because we added something. While Jane was talking, I just fixed it, okay? It took me about 5 minutes to fix, luckily enough, because I'm sitting in JavaScript and I can debug with some of these tools. Exactly the same tools you're using for plotting. So this has general value, okay? What you're sitting on is HTML. How many of you have ever seen an HTML file raw? Like, okay, so good for you guys, and the rest of you, lucky you, okay? But it's actually not very complicated. I remember somebody saying, yeah, I said, do you know a programming language? And they said, yes, I do. And then eventually it became clear that they didn't know what a loop was. And then they said, well, you said you knew a programming language, and they said HTML, and it's not a programming language, okay? You cannot actually do certain things. JavaScript is a programming language. HTML is just a layout, okay? And SVG, who knows what SVG is? Okay, very few. So scalable vector graphics. Okay, it's basically like PDF, except for it's got a whole lot of bells and whistles, and it's built and it's embedded in every browser, which is great. And how many of you have ever written a line of JavaScript code? Okay, excellent. Okay, good. So you've been there. Okay, so this is all this. So basically, it's this combination of let's make a plot in HTML from R. That's what R is shoving out from Plotly or RBokeh or whatever. It's got JavaScript code contained in it, including a thing called JSON, which is JavaScript object notation, which is actually just pretty much what they do is they take the data from R and just stick it in the HTML file and say, we'll make a plot later on. Okay, we're not actually making a plot from R. We're just preparing to make it. Okay, so they generate the HTML file. Okay, it contains the data and information to create the plot. This gets very cryptic in some regards. I've spent a lot of time around in this area, and I looked at it yesterday or the day before, and I'm just going like, what on earth is going on here? It's HTML widgets. The HTML widget that Jane was talking about is hiding stuff because it has to be portable across RStudio and the browser. So it's very hard to see what's going on, and that is a problem. Okay, but basically here's what's actually happening. Let me just do one little thing. Here is my world's simplest scatter plot. This is the motor trend cars data, 32 observations. This is how I debug code. I know there's 32 observations. I know everything about this data set. Okay, so this is just a simple Plotly plot, okay? Okay, so this is actually what's getting constructed, okay? I need to stop doing that. Stop it. It's very ugly code, and my poor little text editor does not like to think of it as HTML, or else it gets very, very slow. This is this document, okay? It's an HTML document. If you haven't seen this, this is how you write. This is how somebody else writes HTML, hopefully, and we can machine generate it. It's an HTML thing. It's got a head. Okay, that's not shown, but it contains all of this. It contains all of the. Come on, you can do it. There we go. So it's got this hideous amount of gibberish. It's got included all the JavaScript libraries just condensed with no spaces, so it's unreadable. Okay, it's just trying to minimize the actual transmission time. And then we get into the real stuff. It's got a body. Okay, this is what's going to actually be the content of the page. You could come in here and edit this later on, okay, and just start changing the text and anything you want. You might as well do it from R, because every time you regenerate this plot, you're going to have to come in and manually do the same changes over and over again. And that's going to get very tedious until eventually you forget to make one of them, and then you change the data, and then you don't update the text. And now you publish this thing, and people are saying that's not the same data. So reproducibility is a really important thing. So what we want is programmatic ability to manipulate these things. To do that, you can use the BS calls function and HTML tools and just constructed from within R. Or the way I like to do it sometimes is I can read this document back into R and manipulate it subsequently. So I can generate it properly, or I can generate it, read it back in, and then edit it. I've got different choices here, lots of choices. But this is all that's happening. We got a body, we got the div. A div is just a division or a divider, okay, just a logical unit, okay. And it's got an HTML widget container. It's got inside in that this is a hierarchical tree. We've got a div. It opens the div. Sorry. Let me go back. We had a head and we have a slash head here, which ends that. So now we're on to another thing. We got the body. The body will end down here. Div is an element of body. This div is inside this div. This attractive number here just uniquely identifies the plot, because there's actually, I don't know how many plots there are in here. We have to go and see, okay? Where's the plot? There is no plot. Okay, that's it. And if we go through this, we'll actually see there's a script, and that's basically it. Let's just do this. Let me just see what we have, okay? We'll come back in a moment, okay? So this is what rather than look at it in the text editor, because it's hard because there's all this garbage in the way that stops me. What I loaded into R through the XML package, parse the HTML. This underbody tell me every single tag HTML element is. There's only 4. Okay, 2 divs. This is the div we saw for the HTML widget container. Okay, that's okay. This is the one for the widget itself, the specific widget, because there's only one plot. And then there's 2 scripts. Okay, that's fine. Okay, so let's just take a quick look at this. I want to know about the scripts. Those scripts actually contain the JavaScript data. Okay, so I just look at them. This one's big, this one's small. Okay, that's fine. There's nothing else lying around the place. They're just the JSON dumps. Here are the, here's what these elements look like, the attributes. It's just, this is the div. It's got some height and width. We've got these 2 application JSON. These are the script files, okay, for sizing it and just the dump. That's it. So let's go back over to here and see what's going on here. So how many of you have ever done this? It behaves slightly different if you're using Firefox, but the same set of tools are there essentially. So you go over to the developer tools, and we end up with this attractive little set of tools. And now we can go over here and look at this. We click on the elements over here. These are the developer tools, and they're very powerful. They take a little bit of time to get used to and to even understand, but you can now see what is going on. Now, what's actually happened is the HTML document has been loaded at this stage. So what's actually happened is we go back over to, where's the simplest way to actually see it? Let me just go back over to here. Let's go back over to here. Come on, you can do it. Okay, so this was our document, okay? So if we go down all the way down to here, come on. Ugh, see how much garbage there is here? Ugh. Now, most of the time you wouldn't actually include this in the file. This is just allows you to pick up that one file and send it in an email. Most of the time we'd actually take all this stuff, stick it out into a separate file so that we don't repeat it over and over again in every single plot. But if we go down all the way to here, oh man, look where we are and look how big this, good grief. So let's go down to body. And there we go. So this is what we see. Div, end of div, the script. Now let's go over here and see. And this again, this is perfectly normal. What do we see? I'm able to, as I highlight these guys, they actually show me what the elements are. This is very helpful, very, very helpful. Okay, but let's go down and take a look at this div. It's got a div. It's got a div. Ooh, we see an extra div, don't we? We had 2 divs, didn't we? Another div. Oh my God, it's divs all the way down. Okay, there's a lot of divs here, okay? So we got a div. So what's actually, the point of this is we started off in the HTML that Plotly generated with 2 divs. And then all of a sudden, a whole lot of stuff got shoved in. Not in the HTML file, but after the HTML file was processed and loaded, there's JavaScript code comes flying in and says, okay, I'll pick up the data and I will start constructing all the interactive elements for the plot. And then they come down into this SVG guy. Okay, scalable vector graphics. Okay, and we see down here, so this is actually so this is all hierarchical. Here we go. So you can customize the heck out of this, by the way, because you can, when you're in R, you can add in all these extra layers. Okay, or you can post-process them if you want. Hang on a second. They don't exist. They only exist later on. But you can actually send across instructions to how to actually make these SVG objects. So where will we look? Ooh, look there. As I mouse over, that's not interesting. That's somewhat interesting. It seems to cover the whole area. This is somewhat interesting. But this guy here, by trial and error, starts getting us into some interesting things. We have no polar layer. We have no ternary layer. That's okay. We got a Cartesian layer. That's great. We got a grid layer. We can, oh, look, we got an X grid. What do you think's in here? This is finally, we're getting to something that actually is going to display. Okay. This is a path, which is just a path. It could be a circle. It could be a polygon. It could be anything. But look, if I mouse over this, we actually see the grid. Okay, so this is finally what's drawing. Okay, and somebody has generated all of these things here. Okay, and let's just see here. There's nothing underneath there. Where do we go? Where do we go? It should be under the Cartesian. Ooh, this is looking promising. By the way, why do you want to be here? Because you want to, potentially, as I say, you may need to debug this. Somehow you may need to actually customize it in some way. See this? We get down to points. Okay, and now as I move over, I actually get the different points. Just to be clear, okay, totally differently from any plot in R that you've ever seen, that point, this point, this point, that line in the grid is an object, okay? And I'm actually going to do something. What'll I do? I'm going to cut and paste some other code, okay? So for those of you, stop it, okay? Yeah, come on. Come on. My poor little text editor is very unhappy with massive files. Come on, you can do it. Where are we going? We're going to do this, okay? This is JavaScript code. Again, I'm not expecting you all to go, well, this is blatantly obvious, or great, I can hardly wait to use this, okay? But I'm trying to show you that it's actually not that hard to actually, if you've done any web scraping, we're going to use the same trick, XPath, okay, for actually finding elements, because we got an HTML document, actually more than an HTML. I'm just going to cut and paste this in very quickly over into my console. I was looking at the elements. I was looking at the HTML tree and the SVG that's inside it. I'm going back to my JavaScript console. I'm just going to, and now I get to type. This is like R. Now we're typing R code, except for it's JavaScript code, and it's fun. Okay. I'm going to need that in a moment. So I'm just cutting it in. Here's what I'm going to actually do. I happen to know by searching, and how did I find it? How did I know to go down and click on all the elements and get to the plot? Because I did the following. I said, show me the G element, the group element that's in SVG, okay, that has a class called points. Okay, and then I said, gotta just do this properly. Okay. And why are you guys? Okay, and it said, oh, it didn't like that. Why am I not happy with this? Oh dear, this cutting and pasting is not happy. We are in scatterplot, aren't we? Yeah, that's odd. We'll get there in a second. So if you yell if you have any questions as to what the heck are you talking about, Duncan? Okay, what have I done? This is XPath. It says, go find me every node. And you see how many times I had to click to open up those silly nodes? And it was div, layers, div, layers. Okay, I just go, yeah, do it for me, will you? Just go through every single part of the tree and find me any node that obeys this characteristic, that has this characteristic. And I got an answer where there was one of them. Okay, so now again, I put this on a Git repository. Okay, so you can see one of them. So I'm just now going to go and do this. If you're not familiar with what I'm doing, hopefully it's just kind of somewhat intuitive. I'm saying, okay, go give me the first element of this thing. Don't ask why we don't use square brackets, just to give me the first element. Don't ask me why we're using 0 for the first element. just to annoy me. Okay, but that's fine. Okay, and now I basically say, okay, go give me this G object, then give me its children, and then give me the first child. I'll get the first child in a second. Okay, so now I go, give me that first child. Okay, there's the path. It's a path. It translates. Okay, it draws it. By the way, this is a circle. Everyone, that's a natural circle. Okay, there's a way in SVG to say, give me a circle, but no, we draw the circle ourselves. Okay, because it does nice things. Okay, but now watch this. Okay, K0, okay, dot, and we're going to do the following. We're going to set the style. I'm going to set the fill color to be red. Watch the points. There it is. We changed it to be red. This is live. This thing is a live object. In R, you can't do this. You have to overplot onto, and you have to know everything about it, and it'll probably trigger redrawing the entire plot. But I can just pick this up. In fact, I can move it. I can just animate it, and I can do all sorts of things. But it's all programmatic. Okay, and this is all that's happening in Plotly. It's just sending it off to a JavaScript library, which does all of this for us. It actually just arranges this, constructs the SVG and adds the tooltips and sets the events on this stuff, and that's all that's going on. So when I click on this, okay, I can arrange to have another plot in the same document do something different, or not even a plot. I could actually have it bring up a sequence of images, and I can do all sorts of things. Is this clear?
Do you think that if you're going to do interactive plots, if you want to ever modify them or do anything customizable, that they're going to be a lot better served by debugging tools in JavaScript than it would be by debugging tools in R?
Well, the great thing about R is you're not there. It ain't happening in R. I mean, that's one of the points I'm trying to make is R doesn't make any plots. R just shoves out HTML and says, I'm leaving that till way later. I mean, you can make it HTML. So what Jane was showing you was you just saw the plot come in RStudio instantly, and you think R's making that plot. They ain't making that plot. You could easily have just written it out to the HTML file, sent it to me, and your computer would never see the plot. And then I load it, and then and only then will the circles and the grid appear, actually be made. Okay, so you can't debug that. There is this other mechanism that we had a long time ago, which is, and you can still use, which is you can generate the SVG for any plot in R. And now it's made as an SVG plot. And then you can rip the hell out of it. You can actually post-process it and do anything you want. It's a little tricky. But that's a whole different ballgame, where one is now we're making the plot in R. We've got all the graphical elements, and you can decorate them before anyone sees them, and then you put them into the browser. This is, yeah, you're way off now into, our debugging tool will only help you with what R is generating for the HTML. And that can be useful. What you really want to do, though, is try to use all these packages so that you stay in R, and it does everything you want. However, going back to what I said, they tend to do canonical things because no one writes a package to do weird arcane things that you want. And because you have to think so hard about how to actually compose an interactive plot or sequence or display, let's say, a collection of plots, there's too many variables. There's too many combinations you could use. So it's nice if you can actually figure out how to do this stuff. You may want to actually, you can take over completely and start building the plots yourself. Okay, but hey, why not just actually use some of the libraries, the JavaScript libraries, and other ones, including D3 and so forth. And then you can glue them together and actually start. So it does help if you can understand this. You don't want to be here, but if you want to be really good at this and do beautiful stuff, you probably want to be here, because you're just going to be too frustrating to be out of here.
I'm sorry, and just the XPath and the children, that's all JavaScript.
The XPath we use in R to do web scraping. Right. Okay, and we use it in Python to do web scraping. We use it all over the place. The beautiful thing about this is, yeah, it's the same concepts. You're just grabbing you're looking at an HTML or XML tree and grabbing the bits that you want, and then programmatically modify them. Now you're not modifying them in R, you're modifying them in JavaScript because you're in JavaScript. And you got a whole different language. JavaScript is so different from R in so many ways, but same kind of concepts. You know, you call a function, you know, you got variables. JavaScript is a funky language. There's no doubt about it. Okay, but you can go off and do things, and you do get this instant gratification. So I mean, if I do this, let's just do this thing here, and then this is I know what I'm doing with SVG. So let's just do this. What I'm actually going to do now is I'm going to make this guy bigger. Okay. No, I'm not, apparently. No, because I didn't cut and paste enough. In fact, I didn't even put it in. Okay, I won't bother doing that. But we can make this bigger. But now we're using SVG. I can put on event handlers, and I can do all sorts of things. So, and you know what's going to happen when Jane shows you about Shiny. All that's happening with Shiny when you have these options, these pull-down menus and radio buttons. Somebody is generating the JavaScript for that, the HTML for that. Somebody is then hooking up JavaScript functions to that. Now the bit that's different is that then when you've made your selection and you hit a button that says go, Shiny is going back to the mothership and actually doing computations in R, which means that's a whole other thing you have to set up. And if you're programming in R, it's much easier because now you're in R and you stay in R and you never leave R, but you need to have a server running, okay, which can be complicated. Whereas what some of the stuff we're doing here is, no, everything is being done in your browser. There's no going back to any mothership, okay, and that can be very helpful. Yep.
Can you create a package that is, it's one of these packages that export to HTML, and then add whatever plot you want to make so that it will export not only the JavaScript code that it does by default, but also get your JavaScript code and then to create the plot you want.
Yes. Yeah. As I say, you can generate that HTML using Plotly, and so there's two things you can actually do. I mean, there's the part of the problem of explaining this is there's so many different ways you could do the same thing. But one of the things you can do is something like this. I think hopefully this is addressing your question. You create an HTML file that Jane created. Okay, so this is scatterplot.html. Okay, now this is just an HTML file. Okay, so if you can do it in R, and you can use sort of things like the div function and the h1 function for a header, and you can put in an image function. You can combine all these with BS calls to essentially lay out a whole lot of complicated stuff. And in there, you probably let's have a plot. Okay, P1 and P2. Okay, now if you know HTML, you can do all of this here. Sometimes it's just easier to do it outside. I would probably do some of this with CSS, cascading style sheets, to do the layout. Okay, but okay, so we can do that. Okay, and you prepare this now. Now you've got your HTML document. Okay, if you need extra JavaScript code, okay, so you can add in other JavaScript files that you need for your own purposes, because let's suppose you're going to actually add some functionality. And I don't know how, unfortunately, there's too many of these packages to know how this works for all of them, because they're all slightly different. Is how do you customize a tooltip? How do you add an event on a particular graphical element? So hopefully they have a mechanism for doing this. If not, here's what I do, okay? And if not, for the faint of heart, okay? There's a little bit of work to be done here, but which is, what are we going to do? I want to add that JavaScript code into this. Very simple thing. Remember we had a head in here? Okay. Well, all I need to do is I need to open this file and add in script. And then I put in an href or a source. I think it's source equals and the name of this file. Okay, relative to where that HTML file is. How do I do that? With a text editor? Sure. Remember I said don't use a text editor because you want this to be reproducible. And so so all we do is you could do read lines in R and just find the head and then stick this line in. Or because we don't like to do that, we just use something like HTML parse. Okay, get the document, find the head node, and insert a new node, and then save it back again. Again, doing this all programmatically. We don't want to use regular expressions because it's just too messy. Okay, so you can do all of that. Another thing you could do though is take this plot. If you don't want to write this, you could just take this plot, the HTML file that Plotly gives you, and go in and find the div. Okay, with the HTML widget. Just grab that, using the same approach here, and lift it and put it into your template. So you write your template file, and what you're going to do is just add this plot. So we had, let's suppose we had this is Jane's plot where you have these data tables and you have the map here and the histogram here. We can just find those three and copy them over here essentially, but now they fit into our bigger template. Again, we're going to do it all programmatically, and now this thing will now have all the extra JS code. And then what I do at the end is I say, okay, I need to. So is this clear? These are two different approaches. And now what I need to actually do over here is I can now it's sort of basically unload. So when the whole plot is loaded, I need to sweep. Okay, so we say unload. We write a little bit of JavaScript code. Okay, so let's go to fix. We have our little routine called fix. Okay, and what will fix do? It'll do exactly what I was just doing over there. Go find me the points and then change them all. Okay, let Plotly build a plot, but let me take over afterwards. Okay, and now I can control anything I want, including, I've got the same plots over here, let's say, but for some reason I decided I want them backwards. Okay, so I can move them around. But not only that, I've got a whole big network over here of something that I'm drawing that makes sense to me. What is this? Pizzas, polling. So now I pull in a whole lot of extra data about the Senate and whose senators are what. And now I click on this and I change these, or I click on this and I change this plot. So I can now customize this all entirely. And how do I do it? By finding the relevant objects. Okay, by just going and finding which parts of the plot are what. Does it make sense? I'm not saying it's easy. I'm just saying it's totally doable. It is actually easy. It's just tedious. It's just extraordinarily tedious. You're much better off not down at this level, but if you have to be, you should be there. But given that R gives you so little flexibility to actually customize some of these things directly, you may have to go over there. Otherwise, you can actually just abandon R and get over into JavaScript. Sorry.
Yeah, I was curious how you make those JavaScript libraries show up in the header. So when I exported the pizza one, it just showed a link to it, but the scatterplots had everything.
Yeah.
Is there a way to do that?
So you have two choices, and as I was saying, one, and this is really annoying that it includes them all for me, because I just like, oh, come on, I just want to I don't want that file to be huge. I want to keep referring to the same files from multiple HTML files, but yet if I want to send you a plot, I want it to be self-contained. So I have to have two choices. So I believe if we go back over here, and we go to here, let's just see. So let's look at library HTML widgets. And we look at save widget. Okay. When I saved it, I used this mechanism. Okay. I said save the widget. Here's the plot I've created. Here's the file. And by default, it's self-contained. That's why all the JavaScript gets shoved into the header. But if I say self-contained equals false, it will put all the JavaScript over into the live directory and just refer to those in the HTML. Does that make sense? So you have that choice and control, and it's all to do with how you actually write it to a file. And if you just print it in R, it doesn't make it self-contained. Okay, so you have to actually do that. And by the way, there's just this other little thing which Jane, you can look at this if you want. There's some very, how you actually put event handlers on is extremely simple. You take your JavaScript, it's very easy to get your layout, then start adding JavaScript. A lot of people do JavaScript by trial and error, and it works pretty well. Here, by the way, Jane was talking about interactive plots. This is SVG. It does animation. It does a whole load of transitions. It does a whole lot of extra stuff that you can use if you want. So you can start making animated plots, okay? And then, when I click on the circle, something actually happens. And then if I go over to here, this is the same sort of thing I was just showing you. So this is all within one plot, so it's okay. But if I click here now, nope, apparently I need to check. I was doing this too quickly. What the code should be doing is actually, when I click here, it goes and finds this line and changes the color, because it's just what I showed you can do interactively. So there's an awful lot you can do with SVG and JavaScript. It really isn't rocket science. It's very straightforward and I find it very easy to build slowly or incrementally, and then all of a sudden I have something that I actually want. When you got two languages, R and JavaScript, and then HTML and SVG lying around, it's really hard to decide where to do it. but knowing both, knowing the basic anatomy should allow you to at least make that choice to actually figure out what's going on. Anyway, that was all I just wanted to illustrate. So, Jane, 2 weeks from now? Good, cool. Well done, Jane.
Hey everyone, I am around a little while if you want to ask questions. Also, kind of mentioned the video will go up. Also, all the stuff will live on my repository. I'll also add it probably to the one that you showed. I'll probably link to it for them, given some issues people had. Yeah. Also,